And then I thought I'll build a decision tree and I'll try to plot how important the cells were by using the feature importances attribute of the decision tree. So I just built a basic decision tree. I didn't set any kind of depth or anything. Created a bar plot of the features, and it told me the bottom left was the most important feature, which is so weird. So what's happening, we're getting different answers. This is my second iteration through it. The first time I got top left. When we do train test split, we're getting different random splits. They're giving us the different things. And if we run it again, we'll probably get a different corner column. So I actually plotted the tree, and the first question it asks is, what's the value of the middle cell? So there's a tension here because we thought the middle cell should be the most important, and that's not matching up with what we got when we did feature importances. And I'm actually glad that we ran into this bug. I did not know this. It turns out that our other approaches that are like more modern, I guess, that one can use. This person, Jeremy Howard, is associated with fast.ai. He is a good data scientist. He says a lot of things that are totally different than what I learned. He's teaching like very contemporary cutting edge stuff. They have their own set of feature importance techniques that they have developed. It's called permutation importance. And what it does is you rearrange the columns and you see how much it impacts. So to use the permutation feature importances, I'm going to have to import them from the sklearn inspection library. And then it's helpful to me to look at the documentation to see what information is available and how I can use it. I see permutation feature importance as a model inspection technique. It can be used for any estimator. It's especially useful for nonlinear estimators like tree-based methods. The way that permutation importance works is it rearranges a column at a time. See how much changing the order affects that. There are some caveats about this. For one thing, if you have two strongly correlated features, it can be misleading. But let's not get too deep into the details. Right now, let's just know that this is another way we can look at feature importance. So now I look at the actual documentation, and I get the importances mean, which is the mean of the feature importance over n repeat. And I get the importances standard deviation, which is the standard deviation over n repeats. And n repeats is a number that I give it. So it does this over and over again randomly, and then it accesses the mean and the standard deviation of the different times that it did it. So I did that to get a result which gave the permutation important, and then I spent a lot of time in the matplotlib.bar documentation to figure out how to arrange this information in a way that was helpful. It probably took me 10 or 15 minutes, and I got several errors. At the end of it, I was able to produce a plot that I loved. And the permutation importance, unlike the built-in feature importance from sklearn, we see that there are three distinct types of cells. There's the other cells, the corner cells, and the middle cell. And these error bars are standard deviations. But we see that the three classes of cells correspond in importance to what we would actually expect. So to summarize, using permutation feature importances gives an alternative method of assessing feature importance. It's helpful to have that in our toolkit as well. Anyway, so the issues that we had actually helped me learn something, which is that I've been putting too much importance in. And they actually have an example where they introduced a completely random variable to a housing price problem. The completely random variable was showing more importance than things that they knew for sure were important. The feature importance's algorithm had a problem. Here they describe permutation importances, and there's another importance that they discuss called drop column importance. And both of those seem to do a better job of capturing what the information that we actually want.